There's something strangely comforting about staring into the abyss of the unknown, isn't there? The deeper you look, the more it stares right back, daring you to ask questions you'll never get answers to. Welcome back to Quiet Universe, where we don't just explore the cosmos. We get lost in it. Tonight, we're going to step off the edge of certainty and drift into the great cosmic riddles that have left even the sharpest minds scratching their heads. The kind of mysteries that don't just sit on the fringes of science, but push against the very fabric of what we think we know. Maybe you've heard whispers of some of them before. The eerie radio signal that blared across the stars for a fleeting moment, never to be heard again. The unexplained tug of galaxies towards something massive and unseen, lurking beyond the observable universe. The cold, empty void in the afterglow of the Big Bang, where there should be heat and light, but instead, there's a silence that stretches for millions of light years. These aren't science fiction. These are real, documented, and so far, completely inexplicable. What if the universe isn't just stranger than we imagine, but stranger than we can imagine? What if there's something out there? Something vast, something intelligent, something ancient, shaping our reality in ways we don't yet understand? Tonight, we're diving into the enigmas that refuse to be solved, the cosmic oddities that gnaw at the edges of reason, and the strange signals that hint at forces far beyond our comprehension. So, sit back, let the silence settle around you, and get ready to drift into the mysteries of the universe. Imagine standing at the edge of a vast ocean, the water stretching endlessly before you, its surface calm, but hiding secrets in the deep. That is our universe. An endless expanse filled with wonders we can barely comprehend, forces beyond our grasp, and mysteries that seem to mock our very understanding of reality. We have spent centuries staring at the stars, building telescopes that reach farther than our eyes ever could, listening to the silent whispers of space, hoping to decode messages written in the very fabric of the cosmos. And yet, with all our progress, there remain questions so profound, so utterly perplexing, that even the greatest minds struggle to find answers. Somewhere in the darkness beyond our galaxy, entire clusters of stars and planets are moving toward an unknown destination, drawn by an invisible force we cannot see and do not understand. Elsewhere, a vast, empty void stretches across the cosmic background radiation, colder than it should be, as if something immense, once stood there and left only silence in its wake. The very foundation of modern cosmology is shaken by a strange alignment in the oldest light in the universe, a pattern that should not exist, a scar on the universe itself. And then there are the signals. Brief, powerful bursts of energy from deep space, flashing across the cosmos like a lighthouse on a stormy night, their origins unknown, their purpose, if any, a mystery. What is out there watching, waiting? Are we truly alone, or have we simply not learned to listen properly? Is the universe as we understand it merely a fragment of something larger, an island in an endless ocean of realities? There are times when science brings us answers, but just as often, it brings us deeper mysteries, questions that unravel what we thought we knew and replace certainty with awe. Tonight, we embark on a journey through the strangest, most confounding anomalies our universe has revealed to us. A journey that will take us to the edge of what we know and leave us staring into the abyss of what we do not. This is not a story of science fiction, nor is it a collection of wild theories meant to spark the imagination without grounding in reality. Everything you are about to hear is real. Every anomaly, every unexplained force, every strange signal has been observed, studied, debated. And yet, in the face of all our knowledge, they remain stubbornly unsolved, silent reminders that, despite all we have achieved, we are still children standing beneath an endless sky, looking up, wondering. So, let us begin. Let us peer into the darkness, listen to the echoes of the cosmos, and try, if only for a moment, to grasp the great, untamed mystery that is our universe. And yet, just when it seemed that the cosmic map was beginning to settle into place, something emerged from the depths of space that defied every attempt at explanation. In 2008, astronomers, peering into the fabric of the universe with the keen eyes of NASA's Wilkinson Microwave Anisotropy Probe, noticed something they were not supposed to see. A strange, almost ghostly motion, a subtle but unmistakable drift of galaxy clusters moving together in a way that could not be accounted for by anything within the known universe. They called it the Dark Flow, a name as ominous as the mystery it carried, and in doing so, they acknowledged that there were forces at play beyond anything they had yet imagined. The universe, as understood, operates under laws that leave little room for such anomalies. Everything we see, from the smallest asteroids to the largest galactic structures, is supposed to move in accordance with the gravitational pull of known cosmic structures. The expansion of the universe itself, a process guided by dark energy, should scatter galaxies in a predictable manner. And yet, here was a vast collection of galactic clusters, millions of light years apart, moving as if some unseen hand was tugging them toward an unknowable destination. It was not a trick of the data, nor an illusion caused by observational errors. This was real, and it was happening on a scale so enormous that even the most seasoned astronomers were left grasping for explanations. This dark flow was not just an anomaly, it was a fracture in the very understanding of reality. The implications were staggering. To account for such a movement, something unimaginably massive had to be pulling on these galaxies, something that lay outside the observable universe itself. The mere suggestion of this was unsettling. It meant that beyond the horizon of what could be seen, beyond the furthest reaches of light that had traveled for billions of years, there existed something vast, something powerful, something perhaps older than the universe as it is known. A remnant of a time before the Big Bang, a structure from a prior cosmos, or even a breach into an entirely separate reality. These were no longer just the musings of science fiction, but actual considerations that had to be reckoned with. For those who had spent their lives mapping the universe, it was like standing on the shore of an ocean only to realize that the true depths were far beyond sight, beyond imagination. Theories emerged, ranging from the mundane to the extraordinary. Perhaps a collection of matter outside the observable universe, something of incomprehensible scale, was exerting this pull. Or maybe the very fabric of space-time itself was revealing cracks, showing hints of hidden dimensions or exotic physics not yet understood. But none of these explanations sat comfortably within the framework of known science. And so, in the grand tradition of discovery, humanity was left with more questions than answers. The dark flow remains a mystery, a silent and invisible force hinting at something greater beyond the cosmic horizon. It is a reminder that no matter how much is learned, the universe will always hold its secrets, and some may forever remain just beyond the reach of understanding. And just like that, the certainty of the cosmos began to waver. It was one thing to acknowledge the vast, empty spaces stretching between galaxies, to accept that the universe was expanding, propelled by forces unseen. But it was another thing entirely to realize that entire clusters of galaxies, each containing billions of stars, each separated by unimaginable distances, were all moving in one direction, as if being pulled towards something beyond the limits of human sight. This was not just motion dictated by gravity within the observable universe. This was a force acting on a scale so vast that it suggested something lurking in the unseen depths of reality itself. The galaxies were not supposed to behave this way. They should have been swept along with the grand expansion of the universe, their movements dictated by the mass and energy within the visible cosmos. And yet, the data told a different story. A silent drift, a great migration of entire galactic superclusters moving toward a point that no telescope, no instrument, no theory had yet been able to define. The more astronomers studied it, the more undeniable it became. Something was out there, far beyond the furthest light that had ever reached human eyes, exerting its influence across cosmic scales. It was as if the universe itself had scars, invisible to the naked eye, revealing that the reality we see is but a fraction of the full picture. This was not a gentle pull, not the subtle influence of some hidden galaxy waiting just beyond detection. This was something else entirely, something that defied even the most generous calculations of mass within the observable universe. The possibilities were as unsettling as they were fascinating. Some whispered of an ancient cosmic structure, something so immense that its gravity reached across the void, tugging on galaxies like a phantom hand from the darkness. Others entertain the notion that this was evidence of another universe pressing against our own, a neighboring reality whose gravity seeped through the thin veil of space-time. The implications were profound, not just for astrophysics, but for the very understanding of existence. If these galaxies were being pulled towards something outside the observable universe, it meant that the cosmos was not merely an isolated bubble, but part of something larger, something far more intricate than ever imagined. The idea of a multiverse, once relegated to theoretical speculation, suddenly carried a weight that could not be ignored. What if the universe was just one of many? What if the unseen force guiding these galaxies was not a structure within this universe, but the gravitational echo of another, pressing against the very edges of known reality? And yet, for all the theories, for all the possibilities, the truth remained just beyond reach. Whatever was out there, it existed beyond the cosmic horizon, in a realm where no light has ever traveled back to tell its story. It is a force that can be felt, measured, inferred, but never seen. And so, humanity finds itself once more at the precipice of the unknown, staring into the abyss of the universe, knowing that something is staring back, hidden in the endless dark. And so the question lingers, heavy in the silence of the cosmos. If galaxies are drifting towards something unseen, something vast enough to leave its imprint on the observable universe without ever revealing itself, then what could it possibly be? The answers, or at least the speculations, stretch beyond the limits of known physics, reaching into possibilities that defy comprehension. Could it be that just beyond the cosmic horizon, hidden behind the impenetrable veil of time and space, there exists a structure so massive, so ancient, that its gravitational pull extends across billions of light years? Or is the truth even stranger? A sign that our universe is not alone, that something beyond it is pressing against the edges of reality itself? If it is a structure, then it must be unlike anything that exists within the visible cosmos. Galaxies, no matter how vast, do not exert this kind of pull across such staggering distances. Even the largest known superclusters, bound together by gravity, do not possess enough mass to influence galaxies millions of light years away in such a coordinated fashion. This suggests something more. A relic, perhaps, of a time before the universe as we know it, an ancient formation left behind by forces long forgotten. Some have speculated that this could be a region of ultra-dense matter, a supermassive collection of galaxies and dark matter so immense that its influence reaches beyond the observable boundary. But if such a structure exists, it raises a chilling question. Why is it outside our cosmic horizon? Did the universe expand in such a way that entire sections of it became permanently separated from our own, forever lost to the depths of space? Or is it possible that this unseen mass comes from something older, something predating even the cosmic inflation that shaped the very fabric of reality? And then, there is the other possibility, the one that forces humanity to rethink its place in the grand design of existence. What if this gravitational pull is not from within the universe at all? What if it is the whisper of another universe, another vast expanse of time and space pressing against our own? The idea of a multiverse, once relegated to the fringes of speculation, now carries a weight that cannot be ignored. If galaxies are being drawn towards something beyond the cosmic horizon, it could mean that our universe is not a self-contained entity, but part of a larger, more complex reality. Perhaps there are other universes, each with their own rules, their own physics, their own histories. Some close enough that their gravity spills over into our own, causing distortions that cannot be explained within the confines of known science. But if that is true, then what else lies beyond the veil? Is this a neighboring universe, parallel to our own, moving on a trajectory that will never allow our realities to meet? Or is this evidence of something even more extraordinary? Collisions between universes, cosmic tides that ebb and flow beyond the scope of human understanding? Some physicists have proposed that our universe may be one of many, existing like bubbles in an endless cosmic ocean. If so, then perhaps what we are witnessing is the distant echo of a universe larger than our own, one whose gravity reaches across the Great Divide, nudging galaxies toward a destination they will never reach. The truth remains elusive, hidden behind the limits of observation, concealed in the depths of space and time. Whatever force is guiding these galaxies, it exists beyond what can be seen, beyond what can be touched, beyond what can even be imagined with certainty. And in that vast, unknowable expanse, there is a lingering sense that reality is far greater than what human eyes have ever perceived. Perhaps one day, with new technologies, new understandings, the horizon will shift and the secrets beyond it will be laid bare. But for now, the universe holds its silence, and the galaxies continue their journey toward a destination that may forever remain out of reach. And yet, it is not just the existence of this force that unsettles the mind. It is the way it behaves. The universe, as far as anyone has ever understood, expands in all directions at once, like an immense fabric being stretched by an unseen hand. Every galaxy, every cluster, every drifting world moves outward in a cosmic dance dictated by the relentless push of dark energy. But this movement, this strange and silent pull on entire galactic superclusters, does not obey the same rules. It is not part of the general expansion, not a mere ripple in the vast cosmic tide. It moves with purpose, with direction, as if something beyond the limits of observation is calling out across the void, pulling everything toward a destination no one can see. That is what makes it so disturbing. Cosmic expansion is predictable, its mechanics well understood. Every galaxy, given enough time, recedes from every other, creating a universe where distances grow infinitely apart. But this is different. This movement does not scatter galaxies evenly across space. It draws them together, guiding them along an invisible path towards something no one can explain. It is not the slow drift of matter within a gravitational field. It is not the aftershock of some long-forgotten cosmic event. It is a deliberate force, one that reaches across billions of light years, exerting its influence on a scale too large to be ignored, yet too elusive to be understood. If it were simply a local disturbance, a fluctuation in the distribution of mass, then it would have an explanation within known physics. But this movement stretches across vast portions of the visible universe, beyond the boundaries of individual galaxies, beyond the reach of anything known to exist. It suggests an influence that is not bound by the familiar laws of gravity, an interaction between our universe and something greater, something unseen. And if that is the case, then the very foundation of cosmology must be reconsidered. Because for this force to exist, there must be something beyond the cosmic horizon. Something that is not just there, but active, shaping the course of galaxies in ways that should not be possible. Perhaps it is a hint that the universe is not alone, that it is part of a larger structure, something interconnected with realities yet to be discovered. Or perhaps it is the echo of a force older than the universe itself, a remnant of a time before the Big Bang, a scar left on the cosmos by something too ancient to name. Whatever the case, it does not behave like anything within the universe as it is known. It is not chaos, not randomness, not the natural dispersal of matter in an expanding void. It is movement with direction, with purpose, and in that, it defies every expectation of what should be. And so the mystery deepens, stretching out beyond the limits of human knowledge, a silent force pulling entire galaxies toward an unseen fate. The universe continues its expansion, but somewhere, beyond the reach of light, something is watching, something is waiting, and something is pulling. Relentless, unwavering, and beyond understanding. And so, the search for answers continues, stretching across the years like the light from distant galaxies, reaching but never quite touching the truth. Scientists, armed with instruments capable of peering into the depths of time itself, have studied this phenomenon with relentless curiosity, hoping to unravel the mystery of this unseen force. Yet, despite all the data, despite all the theories, there is no consensus, no single explanation that ties everything neatly together. The universe, it seems, is in no hurry to reveal its secrets. Some researchers believe that what is being observed is merely an illusion, a trick of gravitational lensing, or an anomaly in the way data is being processed. They argue that what appears to be a coherent movement towards some unseen mass could simply be a statistical fluke, an artifact of how galaxy clusters are mapped across cosmic distances. If that were the case, then there is no great force beyond the observable universe. just the limits of human perception, mistaken for something more profound. But that explanation grows weaker with every new observation, with every confirmation that the motion is real, persistent, and unaccounted for by known physics. Others have taken the approach that what lies beyond the cosmic horizon is simply an extension of what exists within it. A region of space with an exceptionally high concentration of dark matter, or perhaps an unknown supercluster so immense that its gravity reaches across billions of light years. If that were true, it would suggest that our universe is more uneven than once believed, with vast cosmic structures exerting their influence from beyond the limits of observation. But even this explanation falls short, for the sheer scale of the movement suggests something far greater than just a hidden concentration of galaxies. It suggests an influence that extends beyond the laws of known physics, something operating at a level far beyond what human understanding has accounted for. And then, there are those who entertain the more radical possibilities. The idea that what is being witnessed is not just a gravitational anomaly, but evidence of something deeper, something more fundamental about the nature of the universe. Some physicists argue that this could be the first real indication of a multiverse, that the force pulling these galaxies is the shadow of another universe pressing against our own. Others suggest that this could be a relic of an earlier phase of cosmic evolution, a remnant of whatever existed before the Big Bang, exerting its presence even now in ways that defy explanation. Debates rage on in scientific journals and conferences, each theory met with skepticism, each new set of data analyzed and reanalyzed, searching for patterns that might point to an answer. Telescopes capable of peering deeper into space than ever before continue to scan the cosmos, hoping to catch a glimpse of something that might explain the motion of these galaxies. But the problem remains the same. The force pulling them lies beyond the observable universe, in a realm where light has never traveled back to tell its story. For now, all that exists are the questions, the unsettling realization that something enormous, something unknown, is out there, shaping the fate of entire galaxies in silence. And so, the mystery remains, lingering at the edge of human understanding, a force that cannot be ignored yet refuses to be explained. Scientists may not have an answer today, and perhaps they will not have one for generations to come. But the universe is patient, and for those who seek the truth, the search will continue, stretching ever outward, toward the darkness that calls across the void. But the search for answers does not end with galaxies drifting toward an unseen force. The universe has left behind other riddles, imprints of something beyond comprehension, written not in the movement of stars, but in the faint afterglow of creation itself. The cosmic microwave background, the oldest light in the universe, stretches across the heavens like a faded memory, a whisper from a time when the cosmos was young and unformed. It is the remnant of a fire that once consumed everything, the last echo of an age when matter and energy were inseparable, and the universe was a searing ocean of light and heat. Captured in this cosmic afterglow is the story of everything. The birth of stars, the structure of galaxies, the delicate balance of forces that shaped the vast expanse of reality. It is the ultimate record of what came before, a map of the infant universe frozen in time, revealing the tiniest fluctuations in temperature that would one day determine the formation of all that exists. Scientists have studied it relentlessly, poring over its faint ripples and variations, extracting the secrets of the cosmos from a signal that has traveled for nearly 14 billion years. But for all its revelations, it carries something else, something that does not fit the pattern, something that should not be there. Amidst the faint warmth of the universe's earliest days, there is a coldness that defies expectation. A region of space where the background radiation is weaker, its temperature lower than it should be. It is not a mere fluctuation, not just another ripple in the cosmic fabric. It is vast, spanning hundreds of millions of light years, and it is different from anything else in the observable universe. This is the cold spot, an anomaly so profound that it has forced scientists to question whether they truly understand the forces that shaped existence itself. Its discovery was not welcomed as a revelation, but as a problem, a disturbance in what was supposed to be a near-uniform imprint of the Big Bang. The laws of physics, so carefully measured and refined, predicted that such an anomaly should not exist. The universe, in all its randomness, should not allow for something so large, so stark, so inexplicable. And yet, there it was, a silent void in the cosmic tapestry, a whisper from the depths of time suggesting that something unseen had touched the universe in its earliest moments. Theories emerged, each struggling to make sense of the impossible. Perhaps it was an illusion, an error in the instruments, a misinterpretation of the data. But no, the numbers held, and the cold spot remained. Some argued that it might be the result of a vast underdensity of galaxies, a region of space where matter is so sparse that light itself loses energy as it travels through. But even that explanation left gaps, for nothing else like it had ever been seen on such a scale. Others suggested that it might be something else entirely, something not of this universe but beyond it. A scar left by a collision with another reality, a place where the very fabric of existence had been disturbed by forces unknown. And so, the questions persist, stretching across time, defying the certainty that science has tried to impose on the cosmos. The cold spot is not just a temperature anomaly, it is a challenge, a reminder that for all humanity's efforts to chart the universe, there are still places where understanding falters, where reason bends beneath the weight of something greater. It is a message from the past, waiting to be deciphered, an enigma carved into the very structure of space itself. And if the answers are ever found, they may not just change what is known about the universe. They may change what is believed about reality itself. But mysteries like these do not simply announce themselves. They are uncovered, piece by piece, in the quiet work of those who spend their lives chasing the unknown. It was in 2004 that astronomers first noticed something strange in the data from the Wilkinson Microwave Anisotropy Probe, a satellite designed to map the cosmic microwave background with unprecedented precision. They were looking for subtle variations in temperature, the tiny imbalances that would tell the story of how galaxies and clusters formed. Instead, they found something that had no place in the expected order of things. An immense region of the sky where the CMB was colder than it should have been, far larger than any standard model of the universe could explain. At first, there was hesitation, a need to verify, to confirm that this wasn't a mistake, a glitch in the instruments, or a quirk of the analysis. But as the years passed and further observations confirmed its presence, the anomaly became impossible to ignore. It was there, vast and undeniable, a void in the very afterglow of creation. And it wasn't just a minor irregularity. It stretched across nearly 1 billion light-years of space, a cosmic footprint far beyond anything predicted by conventional cosmology. This wasn't just a cold patch in the data, it was a disruption in the very fabric of understanding. Scientists wrestled with explanations, grasping for anything that could account for what had been found. Maybe it was a statistical fluke, an unlikely but not impossible deviation in the random fluctuations of the early universe. Perhaps it was a region where quantum mechanics had played some unexpected trick, a relic of the chaotic birth of space and time. But the more they examined it, the more it seemed to defy simple explanations. The sheer scale of it meant that something extraordinary had to be at play, something that had shaped this part of the cosmos in ways that remained unseen. One idea was that this cold spot might be the imprint of a supervoid, a vast region where galaxies and matter are unusually sparse, a gravitational desert in an otherwise crowded universe. Light passing through such a region would lose energy, creating the appearance of a colder spot in the CMB. But even this was difficult to reconcile with what was known, for no void on record had ever been so immense, so absolute in its absence of structure. And if this was truly a supervoid, it raised the question of why it existed in the first place. Why the universe had allowed for such an enormous emptiness when all models predicted a more even distribution of matter. And then, of course, there were the more unsettling possibilities, the ones that suggested that the cold spot was not a part of this universe at all. Some physicists speculated that it might be evidence of a cosmic collision, a place where our universe had brushed against another, where the scars of that unimaginable encounter were still imprinted in the radiation from the Big Bang. If true, it would be the first direct evidence of a multiverse, a glimpse of something beyond the boundaries of everything that is known. But such an idea, though tantalizing, remains on the edge of what science can prove, lingering in the space between speculation and revelation. Years have passed since that first discovery, and yet the cold spot remains as enigmatic as ever. It is a reminder that the universe is not as simple as equations might suggest, that even in the most carefully mapped territories of space, there are still places where understanding falters. Scientists continue to probe its depths, hoping that with better data, with sharper tools, they might one day peel back the layers of mystery. But for now, it remains what it has always been. An unanswered question, a cold shadow stretching across the sky, a whisper from the dawn of time that refuses to explain itself. But a mystery like this does not simply sit in silence. It challenges everything that was thought to be understood. The universe, as vast and unpredictable as it may seem, still follows rules, patterns written into the very nature of space and time. The cosmic microwave background is no exception. It is not some random scattering of light, but the carefully measured relic of a time when the entire cosmos was a seething mass of energy, still recovering from the moment of its birth. It carries the faint imprints of quantum fluctuations, the seeds from which all galaxies and stars would eventually emerge. These tiny variations in temperature are expected, predicted, and accounted for. But the cold spot is not one of those. It is something else, something that should not be there. In a universe governed by statistical probabilities, there are limits to what is possible. The temperature of the CMB varies ever so slightly across the sky, but these variations have a pattern, a logic shaped by the physics of the early universe. Theories predict that no region should be drastically different from the rest. Certainly not a vast swath of space that appears colder than anything else in sight. If the universe had expanded as expected, distributing its energy evenly across the cosmic horizon, then no single place should stand out so starkly. And yet, the cold spot does. It lingers like a contradiction, a quiet defiance against the symmetry of the cosmos. The reason this is so troubling is that the early universe was not chaotic. It was governed by forces that, for all their complexity, followed an elegant set of principles. When the universe was just 380,000 years old, the moment the CMB was released, it was a nearly uniform sea of light, a perfect blend of heat and energy. The minor fluctuations that existed were natural, expected consequences of quantum mechanics at work in the primordial soup. They were the first whispers of structure, the blueprint from which all galaxies would eventually take shape. But nothing in those blueprints allows for something like the cold spot, a region so dramatically different that it breaks from the carefully woven fabric of the cosmos. If this were a simple fluctuation, it would still be surprising, but not impossible. However, its sheer size and depth defy those odds. Statistically speaking, the chances of a region this cold appearing in the early universe by pure chance are so small that they approach impossibility. If the universe were a calm ocean, the cold spot would be a whirlpool stretching across entire continents, an absence of motion where everything else flows naturally. And this is why it remains so troubling. Because if it wasn't simply a coincidence, then something must have caused it. That cause, whatever it may be, is still unknown. Some scientists have tried to make sense of it within the laws of physics, searching for ways in which the early universe could have produced such a feature. Others have begun to look outward, beyond the known, toward ideas that stretch into the speculative and the extraordinary. But no answer, no matter how carefully constructed, has yet provided the certainty that science demands. For now, the cold spot remains what it has always been. A silent contradiction, an anomaly that should not exist, a reminder that for all the progress made in understanding the cosmos, the universe is still capable of keeping its secrets. But when an enigma refuses to fit into the established order, when every conventional explanation falters under the weight of its own limitations, the mind is left with only one choice: to consider the impossible. If the cold spot is not a mere statistical fluke, if it is not the signature of some yet unknown structure within our own universe, then perhaps it is not of this universe at all. Perhaps it is something more, something that reaches beyond the edges of the reality we know. And that is where the most astonishing possibility emerges. The idea that what we are seeing is not just an absence, but an imprint, a scar left by a collision between our universe and another. It is an idea that, for all its grandeur, has roots in serious physics. The concept of the multiverse, once the realm of philosophical musings and science fiction, has grown into something more tangible, something that theoretical physics cannot simply dismiss. If our universe is not the only one, if there are others, each existing in its own vast expanse of space-time, then it is possible that at some point in the distant past, these universes may have brushed against one another. And if they did, such a collision could leave a mark, a disturbance in the cosmic background radiation, an imprint on the oldest light in existence. Some physicists have entertained the idea that the cold spot might be exactly that. A place where our universe has felt the influence of another, a lingering echo of an event that occurred long before galaxies and stars had formed. If true, it would be the first physical evidence that reality extends far beyond the boundaries of what we can observe, that the vastness of our cosmos is only one small part of a much greater and even more unfathomable expanse. It would suggest that space itself is not infinite in the way we once believed, but rather a bubble adrift in a sea of other bubbles, each a separate universe with its own rules, its own physics, its own unimaginable possibilities. Yet, for all the fascination that this idea inspires, it remains just that. A hypothesis, a whisper of speculation without the solid foundation of proof. Science demands more than wonder. It requires evidence, confirmation, repeatability. And so, the cold spot remains a question without an answer, a mystery balanced on the edge of what can be proven and what can only be imagined. But if the multiverse is real, if there are indeed other worlds beyond our own, then somewhere, perhaps in another reality entirely, someone may be looking up at their own sky, wondering about a strange anomaly in their cosmic background radiation, a cold spot of their own, marking the place where their universe touched ours. But science is not built on wonder alone, nor does it surrender to the allure of the unknown without resistance. For every breathtaking hypothesis, there must be scrutiny, and for every claim that reaches beyond the boundaries of what is known, there must be those who demand a simpler, more grounded explanation. The idea that the cold spot is evidence of a parallel universe is tantalizing, but to many scientists, it is a conclusion drawn too quickly from incomplete evidence, a leap toward the extraordinary when there may still be far more ordinary answers waiting to be uncovered. Some argue that the cold spot is nothing more than a statistical anomaly, an improbable but not impossible fluctuation in the cosmic background radiation. The universe, after all, is vast beyond comprehension, and within its vastness, even the most unlikely events are bound to occur somewhere. If one were to roll 1 trillion dice across the cosmos, a few of them would inevitably land in patterns that defy expectation, not because of some hidden force at play, but because in a system as immense as the universe, even the rarest events will have their moment. The cold spot, they say, may be no more than a cosmic coincidence, a quirk of chance magnified by our own desire to find meaning in the unexplained. Others look not to parallel universes, but to structures within our own. Some studies suggest that the cold spot may be caused by an immense void in the universe, a region of space nearly devoid of galaxies and matter. This so-called supervoid would act like a lens, stretching and cooling the cosmic background radiation as it passed through, creating the illusion of a colder region where in reality, there is simply less matter to interact with the ancient light. It is an explanation rooted in known physics, requiring no speculative multiverse or hidden dimensions. Just a particularly empty stretch of space, vast enough to leave its mark on the oldest light in existence. Even more conservative voices suggest that the anomaly may not be real at all. Not in the way it seems. The data we gather from the cosmic microwave background is filtered through layers of interpretation, mathematical models that try to extract meaningful signals from the noise of the universe. Some skeptics argue that what we see as a cold spot may be an artifact of those models, a trick of the methods used to process the data rather than a genuine feature of the cosmos itself. If so, then all of the speculation, all of the grand theories, may be chasing a ghost, a mirage formed by the imperfections of our own measurements. And so, the debate continues. On one side, the possibility that the cold spot is a window into a reality beyond our own, a hint that the universe is far larger and more complex than ever imagined. On the other, the insistence that before reaching for the extraordinary, one must first exhaust the ordinary, that nature often follows rules more mundane than we would like to believe. But the cold spot remains, silent and unexplained, waiting for the day when science will finally pull back the veil, revealing whether it is the signature of another universe, the shadow of an immense void, or simply a trick of cosmic chance. Until then, it lingers in the night sky. A quiet question without an answer. Building upon what we've explored so far, there's a moment in the story of the universe when everything we know was still tangled in a state of searing, primordial chaos. Before galaxies, before stars, before even the first whispers of structure began to take hold, the universe was a dense, glowing plasma. So hot, so opaque, that nothing resembling light as we understand it could travel freely. But then, something changed. As the universe expanded and cooled, a threshold was crossed, and suddenly, for the first time, light was no longer trapped, no longer scattered endlessly by the charged particles that once ruled the cosmos. It was released, set free to journey across the vast and growing expanse of space, a silent record of everything that had come before. That ancient glow is what we now call the cosmic microwave background, or CMB. A remnant, a fossil of light, whispering to us from the very edge of time itself. And yet, for all its vastness, for all its mystery, there is something oddly simple about it. No matter where you look in the sky, that faint, ghostly radiation seems almost perfectly uniform. A gentle, cosmic hush stretched across the heavens, as if the early universe smoothed itself out with near-perfect precision. And that's exactly what we would expect. The physics that shaped the cosmos in its infancy should have left behind a universe that looks the same in every direction, a testament to the fundamental principles of space and time, to the laws that guide the formation of everything we see. The tiny fluctuations in the CMB, barely measurable differences in temperature, are precisely what we need to explain how the seeds of galaxies, of stars, of entire cosmic structures were planted. But for the most part, the universe seemed to follow the rules, to obey the elegant symmetry that physics so often predicts. Or at least, it should have. Because buried within that delicate tapestry of ancient light, there is something that shouldn't be there. A strange, unexpected alignment. A cosmic imperfection that challenges the very idea that the universe is as symmetrical as we believed. A pattern so peculiar, so persistent, that some have dared to call it the axis of evil. It is as though the cosmos, against all expectation, has a preferred direction, a cosmic asymmetry stretching across the entire observable universe. And that is not something our theories anticipated. The CMB should be random, its tiny variations scattered without bias, with no trace of a grand orientation lurking beneath it all. But instead, this mysterious axis suggests that the early universe may not have been as featureless as we once thought. The implications of this are unsettling. If the universe is not as isotropic as we assumed, if it truly has a preferred direction, it could mean that something far deeper, something woven into the very fabric of reality, is at play. Perhaps an unknown force shaped the infant cosmos in ways we have yet to understand, or maybe our understanding of physics itself is missing a crucial piece. Some have suggested it could be a mere statistical fluke, an artifact of the way we measure the sky, or perhaps even a subtle bias in our instruments. But the more we look, the more it persists, defying easy explanation. It is a reminder that the universe, for all our knowledge, still holds secrets we have yet to unravel. And somewhere, in the silent glow of the CMB, the whispers of those secrets are still waiting to be heard. And so, as scientists peered deeper into the quiet remnants of the early universe, searching for patterns in that faint, ancient glow, they expected to find nothing more than the subtle, random fluctuations predicted by physics. A universe that, on the grandest scales, had no preference, no special direction, no hidden bias. But reality, as it so often does, had other plans. What should have been a chaotic but statistically balanced spread of temperature variations across the cosmic microwave background instead revealed something troubling, something that refused to conform. A peculiar alignment stretching across the heavens as if some unseen force had left its mark on the very blueprint of existence. It was not a single anomaly, not just a small aberration lost in the noise, but a structure. A vast cosmic axis where the CMB's fluctuations lined up in a way that defied explanation. At first, there was hesitation. A discovery like this could not be taken lightly. It had to be an error, an artifact of the way we process the data, a mere trick of perspective. Scientists went back, recalibrated their instruments, checked their methods, scoured the numbers for any flaw that could explain it away. But no matter how many times they refined their approach, the alignment remained. It was real. It was there. And it had no right to be. According to everything we know about the Big Bang, the universe should not have any preferred direction. No up, no down, no cosmic landmark pointing the way. But here was something that suggested otherwise, something that hinted at an underlying structure to reality itself, one that had gone unnoticed for as long as we had been looking. The implications were as unsettling as they were profound. If this alignment was not a mistake, if it was truly written into the fabric of the universe, then it could mean that our most fundamental assumptions about cosmology were incomplete. Could it be that the universe is shaped by forces we have yet to discover, something that lies beyond our current understanding of physics? Could it be a relic of an earlier state of the cosmos, an echo of something that existed before the Big Bang, a fingerprint left behind by a force or an event we have no means of comprehending? Or was it possible that our very place in the universe, the way we observe and interpret the cosmos, was influencing the patterns we saw in ways we had not yet accounted for? Even now, there is no definitive answer. The axis of evil, as it has come to be known, stands as one of the most perplexing mysteries in modern astrophysics. A quiet challenge embedded in the cosmic background, waiting for someone to explain its existence. And as we continue to unravel the secrets of the universe, it serves as a reminder that, for all our equations, for all our models, there are still things out there that refuse to be understood. Somewhere, in the silent depths of space, the universe is whispering a truth we have yet to hear. And so, as the weight of the discovery settled in, as the reality of the strange, inexplicable alignment refused to disappear, scientists were left with a dilemma. They had uncovered something that should not exist, something that defied the very principles upon which modern cosmology was built. A pattern so vast, so eerily consistent across the entire observable universe, that it called into question one of the most fundamental assumptions about space itself. That no direction, no point in the cosmos should be any different from any other. This was not how the universe was supposed to behave. This was not what the Big Bang had predicted. And in their frustration, in their quiet acknowledgement that this alignment stood in stark defiance of everything they thought they understood, they gave it a name laced with irony and unease. They called it the axis of evil. The term itself was never meant to imply something malevolent lurking in the void, nor was it a declaration of doom. It was a reflection of how deeply unsettling this discovery was, how much of a thorn it had become in the side of modern cosmology. Because if the universe did have a preferred direction, if this axis truly existed beyond the limitations of our instruments and our methods, then it meant that the underlying fabric of reality was far more complex than we had assumed. It meant that some unseen force, some yet unknown principle, had influenced the universe at its very birth, shaping it in ways that our current models simply could not explain. For decades, cosmology had rested upon the idea of isotropy, that on the largest scales, the universe is smooth, homogeneous, and the same in every direction. This principle, known as the cosmological principle, is the foundation upon which so much of our understanding is built. The equations that describe the evolution of the cosmos, the distribution of galaxies, the very framework of the Big Bang itself. All of it assumes that the universe has no special orientation, no grand asymmetry written into its structure. But the axis of evil whispered otherwise. If this alignment was real, if it was not some statistical fluke or measurement error, then something was deeply wrong with our understanding of the cosmos. It would mean that, from the very beginning, there was a force or an influence that had given the universe a subtle but undeniable preference. A cosmic fingerprint left behind by a mystery we have yet to grasp. Attempts to explain it have ranged from the mundane to the extraordinary. Some have suggested it could be a relic of an earlier phase of the universe, a clue to a deeper structure that predates the Big Bang itself. Others have speculated that we might be seeing the effects of a multiverse, a neighboring reality subtly influencing our own in ways we cannot yet detect. And then there are those who wonder if the very assumptions upon which modern cosmology is built need to be reconsidered, if the universe is telling us a truth we have long refused to hear. For now, the axis of evil remains a stubborn enigma, a quiet defiance woven into the light of the cosmic microwave background, refusing to be ignored. It is a reminder that, for all the progress we have made, for all the answers we have uncovered, there are still mysteries lingering in the deep, waiting for us to listen. And perhaps, in time, we will come to understand the message hidden in the echoes of the cosmos. Yet, despite the weight of the discovery, despite the unsettling implications of an axis woven into the very structure of the universe, the scientific mind is nothing if not cautious. A mystery of this magnitude demands skepticism. Before appending the foundations of modern cosmology, before rewriting the story of the universe itself, there is one question that must be asked. Could this all be a mistake? Could the so-called axis of evil be nothing more than an illusion, a trick of the instruments, a subtle bias hiding in the way we collect and interpret data? It is a question that has haunted researchers since the anomaly was first noticed, because the simplest explanation, the one that does not require breaking the laws of physics, is that the error is not in the cosmos, but in the way we are looking at it. The first possibility is that the alignment is a byproduct of how we measure the cosmic microwave background. Our instruments, no matter how advanced, are not perfect. Every telescope, every satellite, every method we use to scan the heavens carries with it certain limitations, sources of noise, and potential distortions. The presence of our own Milky Way, stretching across the sky like a cosmic veil, makes it difficult to get a perfectly clean map of the CMB, forcing astronomers to remove its interference through careful processing. But what if, in doing so, we unintentionally introduced a pattern of our own? What if, buried in the complex mathematics of data cleaning, a simple but unavoidable bias crept into the final results, creating an illusion of alignment where none truly exists? Some believe this is the most likely answer, that the axis of evil is not a cosmic truth, but a ghost born from the imperfections of human observation. And yet, the anomaly persists. Even when analyzed using different methods, different techniques, even with the most rigorous attempts to eliminate potential errors, the alignment refuses to vanish. It lingers, challenging those who would dismiss it as mere noise. And if it is not an illusion, if it is not the result of flawed measurements, then the only alternative is that it is real. That the universe is trying to tell us something we do not yet understand. If the axis of evil is truly woven into the fabric of the cosmos, then it hints at something far deeper than a statistical fluke. Some have suggested that it could be the imprint of physics beyond our current understanding, a remnant of forces that shaped the universe in its infancy, long before the CMB was set free to drift across the vast expanse of space. Others have speculated that it may be evidence of a cosmic event so immense that it left a permanent mark on the entire observable universe. Perhaps the result of an interaction with another universe, a subtle but undeniable echo of something beyond our own reality. And then, there are the more radical possibilities, the ideas that stretch the boundaries of what we dare to consider. What if the universe itself is not as infinite and directionless as we assume? What if space has a hidden structure, a pattern we have yet to perceive, one that contradicts the very principle of randomness upon which so much of modern cosmology is built? If this is true, then it would mean that the rules we have used to describe the cosmos, the assumptions that have guided our understanding for decades, are missing a fundamental truth. For now, the answers remain just out of reach. Whether the axis of evil is a mere trick of observation or a glimpse into something far greater, it stands as a quiet challenge, a question the universe has posed to us without offering an easy answer. And perhaps that is the beauty of it, that even in the vast stillness of space, Even in the oldest light that reaches us, there are still mysteries waiting to be unraveled. Mysteries that remind us how much more there is to learn, how much more the cosmos has yet to reveal. And so, the question lingers in the silence of space, heavy with possibilities. If the axis of evil is not an illusion, if it is not a mere artifact of measurement, then we are left with a reality that is far more unsettling, far more profound. It would mean that the universe is not as we have long believed it to be, that beneath the comforting equations and elegant models, something deeper stirs, something we have yet to comprehend. The very fabric of space itself might not be the neutral, isotropic expanse we once assumed, but instead, a canvas marked by forces unknown, shaped by patterns we never thought to look for. The implications of such a discovery stretch beyond mere curiosity. The foundation of modern cosmology rests upon the assumption that the universe has no preferred direction, that from any vantage point, the cosmos should appear more or less the same. If an axis truly exists, if the largest scale structures of the universe are imprinted with a direction, then it suggests that something in the early universe, perhaps even before the cosmic microwave background was formed, left a scar upon reality itself. It would call into question the very principles that guide our understanding of cosmic evolution, forcing us to reconsider whether the Big Bang was as uniform as we had once believed. Some have speculated that the answer may lie in new physics, in forces or laws that extend beyond what we have yet uncovered. There are whispers of modified gravity, of unknown interactions that may have subtly shaped the structure of the cosmos in ways we cannot yet explain. Others look to the possibility of extra dimensions, hidden realms of reality whose influence might be written across the sky in ways we have failed to recognize. And then, there is the most daring notion of all. The possibility that our universe is not alone, that what we perceive as an unexplained alignment might be a lingering trace of an interaction with something beyond our own cosmic horizon. A neighboring universe, a force from outside our reality, an echo of something that transcends the very boundaries of existence as we know it. If true, it would be one of the greatest discoveries in the history of science, a crack in the cosmic mirror revealing a glimpse of a deeper truth. It would mean that the universe is speaking to us in ways we have only begun to understand, that the patterns written in the oldest light are not mere coincidence, but a message left behind by forces we have yet to name. And perhaps, in time, we will learn to read that message. Perhaps we will find within it the missing pieces of a puzzle that stretches beyond the reach of our understanding, a puzzle that has been waiting, across the vast silence of space, for us to finally see it. But the mysteries of the cosmos are never confined to just one anomaly, one unexplained phenomenon written in the light of the past. If the axis of evil calls into question the very nature of the universe's structure, then the great attractor forces us to confront something even more unsettling. An unseen force, vast beyond comprehension, warping the motions of entire galaxies like an invisible tide beneath the surface of existence. It was in the 1970s that astronomers first began to notice something strange. Galaxies, including our own Milky Way, were not merely drifting through space as expected, but instead moving with a peculiar urgency, drawn toward a region of the sky that seemed, at first, to contain nothing at all. The more they studied it, the more undeniable the motion became. Something was out there, something massive enough to bend the trajectories of entire galactic superclusters, yet hidden from view, veiled behind the thick curtain of the Milky Way's own stars and dust. It was a discovery that defied intuition. The universe, after all, is supposed to be expanding in all directions, galaxies racing away from each other in the grand aftermath of the Big Bang. And yet here was a force strong enough to resist that expansion, a gravitational well so deep that it could bend the very flow of the cosmos itself. The realization was as thrilling as it was unsettling. When astronomers finally managed to peer beyond the dense clouds of our own galaxy using radio waves and infrared observations, they saw what had been tugging at them all along. An immense region of clustered galaxies, bound together by an overwhelming gravitational influence. But even then, the puzzle only deepened, because what was visible did not account for the sheer magnitude of the pull. There had to be more, something greater, something lurking in the darkness beyond the limits of what we could yet observe. And so, The Great Attractor became not just a name, but a riddle. It is not a single object, not a simple point in space where gravity collects its winnings. It is a region, a deep gravitational valley carved into the landscape of the cosmos, where unseen forces have shaped the destinies of galaxies for billions of years. Some theorized that it was part of an even larger structure, something stretching beyond our current field of vision, something woven into the vast tapestry of the Lania Chaos supercluster, the immense web of galaxies to which our own Milky Way belongs. Others suggested that much of its pull might be explained by dark matter, that elusive, unseen substance whose presence can only be inferred through the gravity it exerts. But even with these explanations, something remains haunting about it. The idea that we, along with all the galaxies we see, are being pulled toward an unknown force, toward a part of the universe we may never fully understand, is both humbling and profound. It is a reminder that the cosmos is not merely an empty void dotted with distant stars, but a living, shifting structure where unseen hands still shape the dance of galaxies, where forces beyond our current grasp continue to whisper in the fabric of space itself. And as we drift toward that gravitational abyss, pulled ever forward by a force we cannot yet name, we are left with the quiet realization that our place in the universe is not one of stillness, but of motion. An endless journey toward the unknown. And so, the pull of the Great Attractor is not just some distant curiosity, some abstract force shaping galaxies far beyond our reach. It is something much closer, something woven into the very motion of our own Milky Way, something that exerts its quiet influence on the path we take through the vast, unfolding fabric of the cosmos. For all the stars that make up our galaxy, for all the luminous clouds of gas and the unseen mass of dark matter that holds it together, the Milky Way is not motionless. It is being drawn, ever so steadily, toward a destination we do not yet fully understand. When astronomers first measured the peculiar movement of our galaxy, they found that it was not simply riding along the general expansion of the universe, carried outward like everything else in the aftermath of the Big Bang. There was an additional motion, something unaccounted for, a velocity that tugged us toward a specific region of space at nearly 2 million kilometers per hour. It was an unsettling realization, because for all the careful models and equations that governed our understanding of cosmic motion, this was an influence that defied easy explanation. And then, when they turned their instruments outward, they saw that we were not alone in this drift. The entire local group, the collection of galaxies to which the Milky Way belongs, was moving in the same direction. So was the greater Virgo cluster beyond it. And beyond that, even more distant superclusters all seemed to be following the same gravitational pull, as if a silent tide was drawing them all toward a point beyond the horizon of what we could clearly observe. This was the force of the Great Attractor, a mass so immense that it alters the very structure of motion on a cosmic scale. But its significance runs even deeper because it hints at a universe far more interconnected than we once imagined. If our galaxy, along with countless others, is being drawn towards something we cannot fully see, then it means we are part of a vast and intricate web of forces, one that extends far beyond the limits of our own celestial neighborhood. And if there is something larger still, something even more massive lurking just beyond the veil of observation, then our understanding of the universe's architecture may still be in its infancy. It is a humbling thought to know that the Milky Way is not adrift in empty space, but caught in the grip of something far greater than itself. That for all our scientific achievements, for all the instruments and theories that have brought the universe into clearer focus, there are still forces at work that we do not yet fully grasp. And as our galaxy continues its silent journey, drawn inexorably toward this unseen mass, we are left with the realization that we are part of a story far older, far grander than we ever imagined. One written not just in the stars, but in the very currents of the cosmos itself. And so, as the Milky Way drifts toward this unseen force, as countless galaxies follow the same mysterious pull, the question lingers. What is the Great Attractor? Is it something we can one day fully comprehend, or is it merely the edge of something even greater, something hidden beyond the limits of our sight? For years, astronomers wrestled with this enigma, turning their telescopes toward the region where the pull seemed strongest, searching for a definitive source, a structure massive enough to account for the strange motion of entire galactic superclusters. One theory suggested that the Great Attractor was itself a colossal concentration of galaxies, a supercluster far more massive than any we had yet identified. Galaxies do not move at random. Their paths are shaped by gravity, by the massive filaments and knots of matter that stretch across the universe like an intricate web. If the Great Attractor were a supercluster, it would mean that we were witnessing the slow, inevitable motion of galaxies caught in the gravitational embrace of something truly vast. A dense, sprawling structure whose sheer mass dictated the movement of everything around it. But there was a problem. When astronomers pointed their instruments at the region where the Great Attractor's pull seemed to originate, they did not find a supercluster of overwhelming size. There were galaxies, yes, great swarms of them, but not nearly enough mass to fully explain the force that was shifting the motion of entire galactic neighborhoods. It was as if the answer was still hidden, just out of reach. And then, the realization set in. Perhaps the Great Attractor was not a singular object, not just one massive collection of galaxies, but a signal of something even larger, a clue to an even deeper structure of the universe. Some suggested that beyond it lay something even more massive, something lurking in the shadows of the cosmic map, the Shapley supercluster, a truly gargantuan collection of galaxies far beyond the Great Attractor, whose combined gravitational influence could be shaping the motion of the Milky Way and countless other galaxies. If true, then the Great Attractor was not the final answer, but merely the first step in unraveling an even greater mystery, one that spoke of structures spanning hundreds of millions of light years, of forces at play on a scale beyond anything we had previously imagined. Yet another possibility loomed in the background, a more unsettling one. What if what we were seeing was not just a cluster of matter, but an indication of something deeper, something hidden from view not by distance alone, but by the very nature of our universe? The Great Attractor lies in a region of space obscured by the thick dust and gas of the Milky Way's own plane, a region where visible light struggles to pass, where our instruments fight to pierce through the darkness. Could it be that we are looking at only a fraction of the true structure, that what we have glimpsed is only the tip of a gravitational iceberg, its full mass hidden from sight by the cosmic dust that veils it from us? Or worse still, could it be that there are forces at play that we do not yet understand, forces beyond the simple pull of visible matter, something that warps the motion of galaxies in ways we cannot yet explain? The search continues as astronomers refine their models, as they develop new ways to see through the cosmic veil that hides so much of our universe. With every new discovery, with every deeper probe into the structure of space itself, the hope remains that one day we will look back at this mystery and see the full picture at last. But for now, the Great Attractor remains just beyond our grasp, a silent force drawing us forward, reminding us that even in this age of great knowledge, the universe still holds secrets far greater than we can yet comprehend. And so, as the mystery of the Great Attractor lingers, as galaxies drift toward an unseen force with no clear source, the question remains: how do we finally unveil what lies hidden beyond the thick veil of cosmic dust, beyond the limits of our current technology, beyond the reach of the instruments that have served us so well yet still leave us staring into darkness? The answer, as it has so often been throughout history, lies in the future, in the next generation of space telescopes that will peer deeper, see clearer, and uncover what has long remained just beyond our grasp. The limitations of our current observations stem not from a lack of curiosity or effort, but from the simple constraints of the tools we have at our disposal. Most of our maps of the universe rely on visible light, on what can be detected by telescopes that capture the glow of galaxies scattered across the cosmos. But the region where the Great Attractor resides is shrouded in the thick dust and gas of the Milky Way's own plane, a barrier that makes direct observation nearly impossible with traditional methods. Future telescopes, however, will not be bound by such limits. Infrared observatories, like the recently launched James Webb Space Telescope, are already peering through cosmic dust with an unprecedented clarity, revealing structures and details that have remained hidden from view. But Webb is only the beginning. The next generation of space telescopes will push even further, combining infrared, radio, and X-ray observations to map the universe in ways never before possible. The Nancy Grace Roman Space Telescope, with its wide-field infrared capabilities, will scan enormous portions of the sky, capturing details of galactic movements and distributions on a massive scale. The European Space Agency's upcoming Euclid mission will chart the large-scale structure of the universe with exquisite precision, tracing how galaxies are arranged and how dark matter shapes their motion. And beyond these, the proposed successors. Concepts like NASA's LUVOIR or Habitable Worlds Observatory promise to bring an even sharper eye to the depths of space, resolving finer details, detecting fainter objects, and finally revealing the full mass and structure of what lies in the zone of avoidance, where the great attractor lurks unseen. But there is another frontier waiting to be explored, one that extends beyond mere light, beyond the visible, the infrared, the X-ray. The future of cosmology will not just be about what can be seen, but what can be felt through the very fabric of space itself. The growing field of gravitational wave astronomy holds the promise of detecting the subtle ripples in space-time caused by massive cosmic structures, allowing us to sense the gravitational influence of unseen masses in ways we never could before. If there is more to the great attractor than meets the eye, if its pull is stronger than what visible matter accounts for, gravitational wave detectors like LISA, the Laser Interferometer Space Antenna, could provide clues about the nature of this hidden force, whether it is truly just a cluster of galaxies or something far stranger, something that defies the models we have relied upon for so long. And then there is the possibility that the answer lies in the unseen itself, not just in the galaxies we struggle to observe, but in the very nature of the universe's invisible matter. Dark matter, that elusive substance that neither emits nor reflects light, yet accounts for most of the gravitational pull in the cosmos, could be playing a central role in the mystery of the great attractor. Future experiments, whether through direct detection attempts here on Earth or large-scale mapping projects in space, may finally reveal whether this unseen matter is the key to explaining the strange motions of galaxies, or whether an even deeper mystery lies waiting to be uncovered. In the end, the search for the great attractor is not just about solving one cosmic puzzle. It is about pushing the boundaries of what we know, about peeling back the layers of the universe one by one, revealing the hidden forces that shape our reality. With every new telescope, with every refined observation, we take another step toward understanding what lies in the darkness, toward seeing the invisible, toward answering the questions that have pulled us forward for so long. Just as surely as the great attractor pulls our galaxy through the cosmos toward an unknown future that we are only beginning to glimpse. And then, as if the universe itself decided to whisper into our instruments, a signal appeared, not with the slow buildup of a distant, predictable pattern, but in a sudden, fleeting burst of something that had never been heard before. It was 1977, a time when humanity's ears were just beginning to stretch beyond the limits of our own solar system, listening, hoping, wondering if somewhere out there, someone, or something, might be trying to speak back. And then, for exactly 72 seconds, the radio telescope at Ohio State University, a giant steel ear aimed at the depths of space, caught a signal so distinct, so unlike the usual cosmic noise, that the astronomer who first saw it circled the printout in red ink and wrote one word beside it. Wow! For all the noise the universe makes. Pulsars spinning like celestial lighthouses, quasars humming with the fury of black holes, the background radiation left over from the birth of time itself. This signal was different. It wasn't just another random fluctuation, not just a wandering satellite bouncing its message off the heavens. This one came in on a very specific frequency, 1420 megahertz, the exact wavelength that hydrogen naturally emits, a frequency that, by cosmic coincidence or deliberate design, is also one of the few channels in the radio spectrum where there should be nothing but silence. No natural sources we know of should have been able to produce a signal like this, at least not in the way it appeared. Strong, perfectly tuned, and then gone, like someone knocking on the door of the cosmos and vanishing before we could answer. And yet, for all its mystery, the wow signal remains just that. A single moment in time, an unanswered question scrawled in the margins of our understanding. Attempts to find it again have come up empty. We've pointed our instruments back at the same patch of sky in the direction of the Sagittarius constellation, where it once briefly flickered into existence, but the silence that followed has been absolute. If it was a message, no one has repeated it. If it was an accident, it has never happened again. And if it was something else entirely, something beyond our understanding, then we are left only with speculation, the ghost of a signal haunting the edges of our knowledge. And so, the WOW signal remains one of the greatest cosmic riddles ever recorded, a whisper from the unknown, a brief alignment of forces that left behind no trace beyond a piece of paper and the collective wonder of those who still gaze into the abyss, waiting, listening, hoping that one day, whatever sent it might speak again. And so, with nothing but a red-circled wow and a silence that stretched endlessly in every direction, something changed. Not just for the astronomers who spent their nights scanning the heavens, but for the entire pursuit of intelligent life beyond Earth. Before that night in 1977, the search for extraterrestrial intelligence had been more of an idea than a reality. A quiet dream shared by a handful of scientists who pointed their radio telescopes at the sky with little more than hope and patience. The universe was vast, its possibilities endless, but the proof had always been missing. Until, for 72 seconds, it wasn't. That signal, so brief and yet so precise, became a beacon not just in its content, but in its implications. If such a thing could happen once, it could happen again. If something, somewhere, had reached across the void, even for an instant, then perhaps there was something out there worth listening for. And just like that, the search became something more than an abstract curiosity. It became a mission. Telescopes that had once been tuned to the cold, impersonal frequencies of deep space phenomena now had a new purpose. To find another signal like it, to catch another fleeting whisper from the stars before it slipped back into silence. Funding that had once been scarce began to flow, if only in trickles, and researchers who had struggled to justify their work now had a single, undeniable anomaly they could point to, a mystery that begged to be solved. More powerful instruments were brought to bear, algorithms were rewritten, new methods of filtering cosmic noise were developed, all in the hope that whatever spoke that night in 1977 might speak again. And when it didn't, when the sky remained quiet, the search did not fade. It only deepened. Because once the possibility had been glimpsed, it could not be ignored. The discovery of fast radio bursts, strange emissions from the depths of the universe, the study of exoplanets orbiting distant suns, the realization that the cosmos was far richer in habitable worlds than anyone had imagined. It all grew from that single moment, that one unexplained pulse of radio waves that shattered the illusion that we were only listening to silence. And so, the WOW signal became something more than a signal. It became a question that could not be forgotten, a mystery that still waits for an answer. It set in motion a search that has only grown more relentless with time, a search that continues to this day, as new telescopes scan deeper, as new minds join the effort, as humanity refuses to accept that the universe might be empty. Because once you've heard even the faintest echo of something beyond yourself, the silence can never feel the same again. And so, the silence of the universe was forever changed by a single signal, a fleeting moment that left behind more questions than answers. But it wasn't just the mystery of its origin that made the WOW signals stand apart. It was the way it arrived, the way it stood out against the ever-present hum of the cosmos, as if it had been crafted with purpose. In a universe filled with chaotic radio emissions, with the endless static of dying stars and the random bursts of cosmic radiation, this signal was something different. It was strong, unwavering, and narrowband, a quality that no known natural phenomenon should have possessed. Radio waves from space are usually messy, spread across multiple frequencies, like the indistinct crackling of a distant storm. But this signal was focused, precise, a single frequency at 1420 megahertz. So sharp it might as well have been etched into the fabric of space itself. And that was what made it special. Because 1420 megahertz is not just any frequency, it is the natural resonance of hydrogen, the most abundant element in the universe, a frequency that, by international agreement, is kept clear of human interference. It is the one place on the radio dial where the cosmos should be quiet, where any signal detected has to be something worth paying attention to. If an intelligent civilization wanted to send a message across the void, this would be the cosmic calling card they would use, the one place where their signal would have the best chance of being heard. And for 72 seconds, it was. It did not drift, did not waver, did not fade in and out like a passing satellite or a natural burst of energy. It arrived with a strength that built rapidly and then fell away just as quickly as though something, somewhere, had sent it with intention, as though it had passed through space like a lighthouse beam sweeping across a dark and endless sea. And yet, despite its clarity, despite its precision, it was never heard again. No known celestial object produces signals like this, no pulsar, no quasar, no nebula. Nothing we have ever encountered behaves in quite this way. The possibilities stretch from the mundane to the extraordinary. A secret military transmission bouncing off some unknown surface, a rare and unknown space phenomenon, a fleeting anomaly in Earth's atmosphere. Or, just maybe, the briefest whisper of something else, something waiting beyond the reach of our understanding. And so, it remains a puzzle without an answer, a moment frozen in time, a single note in the grand symphony of the universe that has yet to be repeated. Whatever it was, wherever it came from, it was unlike anything we had heard before or since. It lingers not just in our records, but in our collective imagination, a quiet, persistent reminder that sometimes the universe speaks in ways we have yet to comprehend. And so, with all its precision, all its impossible clarity, the wow signal left behind a silence that has stretched on for nearly half a century. Because the universe, in all its vastness, is not in the habit of offering easy answers. If it had come again, if that same frequency had lit up our instruments just once more, then perhaps we would have something more than speculation, something more than a red circle and a lingering sense of wonder. But it has never returned. Not in the same place, not at the same frequency, not in any way that could confirm what we heard that night in 1977 was anything more than a cosmic accident. And that is what makes it so elusive, so frustratingly out of reach. A discovery in science is only as strong as its ability to be tested, observed, repeated. Without that, it becomes little more than a story, an event locked in time, forever open to doubt. Telescopes have been turned back to that same patch of sky countless times by different researchers across generations, each one hoping to catch the faintest echo of what was once there. But the heavens have remained silent, indifferent to our curiosity. If it was an artificial transmission, something sent deliberately from a distant civilization, then why only once? Why not a second attempt, a pattern, a message with structure? And if it was something natural, some yet to be understood astrophysical phenomenon, then why haven't we seen it anywhere else in the universe, in all the thousands upon thousands of hours spent listening? There are theories, of course. Perhaps it was a signal from something moving, a transient burst from a distant source that just happened to pass through our field of view for those 72 seconds, never to return. Perhaps it was a reflection of something closer to home, a rogue transmission from Earth bouncing off some unknown surface before vanishing into the void. Or perhaps, just perhaps, it was a deliberate message, a signal sent by an intelligence that, for reasons we may never understand, had no intention of repeating itself. But the truth is, we do not know. And until it happens again, if it ever does, we will remain in this state of uncertainty, caught between wonder and skepticism, listening to the silence and hoping that somewhere, out in the great unknown, whatever sent that signal might one day decide that we are worth speaking to once more. And so, the silence that followed only deepened the mystery, forcing us to turn inward, to sift through the possibilities with nothing but our own reasoning to guide us. Because if the wow signal was not just an ordinary fluctuation in the cosmic static, then what was it? If it did not return, if it left no trace beyond a fleeting moment in 1977, then we are left with only theories. Two opposing possibilities, each as compelling as it is uncertain. On one side, the familiar, the natural, The possibility that somewhere in the vast machinery of the universe, there exists a process we do not yet understand, something capable of mimicking intention without ever meaning to. And on the other, the extraordinary. The idea that what we heard was not an accident, not a trick of physics, but a whisper from intelligence itself, a deliberate beacon in the endless dark. To believe in a natural explanation is to admit that the cosmos is still full of surprises. Perhaps it was a rare and momentary alignment of interstellar phenomena, something akin to a pulsar, but stranger, something that emits not in rhythmic pulses, but in singular bursts, waiting undetected in the depths of space. Perhaps it was a reflection, a fragment of energy bent and redirected by a gravitational lens, warped by the pull of some massive celestial body between us and its true source, distorting a more distant radio emission into a moment of perfect clarity before scattering it forever. Or maybe it was something as simple as a comet, an icy traveler trailing behind it a cloud of ionized hydrogen that, under the right conditions, could produce just the kind of signal we heard. Though if that were the case, we would have expected to see it again, each time the comet traced its orbit back through our sky. And yet, we have not. But if we allow ourselves to entertain the other possibility, the one that lingers in the imagination, the one that stirs something deep within us, then we must ask, what would an artificial signal look like? Would it be exactly like this? A single pulse, sent out not as a conversation, but as a marker, a flare in the night, a message that says, we are here, with no expectation of a reply? Would an advanced intelligence, reaching across the incomprehensible distances of the galaxy, choose to send something that only the most patient and curious among us would ever detect? A signal that does not repeat, does not demand to be noticed, but simply exists, waiting to be found? If it was artificial, if it was deliberate, then the true mystery is not just what was sent, but why it has never come again. Was it meant for us at all, or were we nothing more than accidental eavesdroppers on a conversation never intended for human ears? Was it a transmission from a civilization that, by the time we received it, no longer existed? Or was it a test, a single note in an ongoing experiment, waiting to see if anyone on our small, fragile world would recognize it for what it was? And so, we are left with the paradox of the wow. Signal, caught between what we know and what we suspect, between the comfort of the ordinary and the lure of the extraordinary. Until the day comes when the silence is broken again, until we hear another signal that forces us to look at the universe in a different way, the question will remain unanswered, lingering like an echo of something just beyond our understanding. Something waiting, perhaps, to be heard once more. And so, the debate continues, stretching across decades, across generations of scientists and dreamers alike. Because despite all the attempts to explain it away, despite every natural theory that has been put forward, there are still those who believe, who cannot let go of the possibility that, for 72 seconds in 1977, humanity may have heard something truly extraordinary. And perhaps they believe not just because of what the wow signal was, but because of what it wasn't. It wasn't random background noise, it wasn't an Earth-based interference, it wasn't anything that fit neatly into the well-understood mechanisms of the universe. It was something else, something deliberate. And if it wasn't us, then who else could it have been? The strength of the signal alone makes it difficult to dismiss. Whatever it wasn't weak, wasn't struggling to be heard through the endless static of the cosmos. It arrived as if it had been sent with intention, as if it had been aimed, even if just for a moment, right at us. And then there is the matter of its frequency. 1420 megahertz, the hydrogen line, the one part of the radio spectrum that is both universally significant and deliberately kept clear of human interference. Hydrogen is the most abundant element in the universe, the very building block of matter itself, a frequency so fundamental that if any intelligent species were to attempt interstellar communication, it would be the one place they would choose to send a message. And that is precisely where the wow signal was found. But perhaps what keeps the belief alive more than anything is the silence that followed. If it had been a natural event, if it had been something as simple as a comet or a passing reflection, then we should have seen it again. We should have been able to trace its origin, to study it, to find others like it scattered across the universe. But we haven't. No known astronomical object has repeated the signal. No phenomenon in the vast catalog of cosmic activity has behaved in quite the same way. And that, for many, is what makes it feel more like a message than an accident. Because an intelligent transmission, one that was sent with purpose, would not necessarily repeat. It would not behave like a pulsar or a quasar or a cosmic flare, predictable and regular. It might be a single beacon, a one-time pulse sent across the void, waiting for someone, somewhere, to hear it. And then there is the unsettling possibility that we were never meant to detect it in the first place. That we overheard something far beyond our understanding, something that was never meant for human ears. A distant civilization sending out a call, unaware that, in a quiet observatory on Earth, an astronomer named Jerry Emin would stumble upon it, would mark it with a simple word, "Wow!" and would unknowingly start a search that has never truly ended. Perhaps they never sent another, or perhaps they have, but we were never listening at the right moment, in the right place, with the right technology to catch it again. And so, the belief persists because the alternative, that the universe has been silent all along, that there was never anything beyond that single fleeting moment, is somehow harder to accept. Because once you hear something like that, once you glimpse even the possibility of a voice in the darkness, the silence that follows will never feel the same again. And so, the search has never truly stopped. Decades after that fleeting moment in 1977, radio telescopes have continued their patient listening, combing through the endless waves of static that pour in from the cosmos, hoping to find another whisper. Another anomaly that refuses to fit within the neat, familiar boundaries of natural explanation. And while nothing has quite captured the imagination like the WOW signal, there have been others. Strange, elusive signals that, for a moment, made us wonder if we were hearing something not of this world. Among them, SHGP-02+14a and the Northern Cross Anomalies stand as quiet reminders that the universe still holds secrets, that even in the silence, there are unexplained voices waiting to be understood. SHGP-02+14a was one of the most tantalizing finds to emerge from the SETI at Home project, a program that turned millions of ordinary computers into a vast, distributed listening array. Sifting through the data collected by radio telescopes in search of something that might not be random. It was an experiment in patience, in human curiosity stretched across countless homes and offices, each screensaver displaying swirling graphs of unknown transmissions from deep space, each participant unknowingly part of a great cosmic vigil. And in that ocean of noise, something unusual surfaced. A signal, detected multiple times, seeming to originate from somewhere between the constellations Pisces and Aries. An empty stretch of sky with no known planets, no obvious sources of human interference. It was faint, drifting in frequency as though it had been sent from something moving, perhaps a planet rotating, a beacon shifting ever so slightly as it crossed the vast interstellar distances. And yet, just like before, just like with WOW, it never returned. No second transmission, no repeat detection. Just a brief signal that defied easy explanation and then faded back into the void. The Northern Cross anomaly was even stranger. Picked up in 1997 by an Italian radio telescope, it was a short, powerful burst that behaved unlike any known natural radio emission. No pulsar, no quasar, no supernova could account for what had been detected. It had the clarity of something artificial, something intentional. But much like everything else in this long, lonely search, it vanished before it could be studied, leaving behind nothing but a question and an empty sky. And that is the cruel reality of signals like these. In the end, without repetition, without verification, they remain unsolved. Were they real? Were they echoes of something distant and intelligent, lost in the vastness of space before we could listen again? Or were they nothing more than the ghosts of our own technology, the hum of earthly interference bouncing through the atmosphere, tricking our instruments into believing we had heard something more? The difference between discovery and illusion in the search for extraterrestrial intelligence is razor thin, and without confirmation, Even the most promising of signals eventually fade into uncertainty. But still, we listen. We listen because we have heard just enough to believe that something might be out there, waiting, reaching across the darkness in ways we have yet to fully understand. And maybe one day, the silence will break again. Not for 72 seconds, not for a single fleeting burst, but for something undeniable, something that leaves no doubt that we are not alone. Until then, we wait. And so, the search pressed on, shifting its gaze from the fleeting whispers of singular anomalies to something even more perplexing. Signals that did not simply appear and vanish, but instead pulsed again and again, demanding to be noticed. If there is one certainty in the cosmos, it is that nature tends to follow patterns, rhythms dictated by physics, cycles that can be predicted, measured, and understood. But every now and then, something defies expectation, something emerges from the darkness that does not behave as it should. Fast radio bursts, or FRBs, were first stumbled upon by accident, brief explosions of radio energy so powerful and so distant that they seem to come from the farthest reaches of the universe itself. The first official discovery came in 2015, though older data hinted that they had been happening for years without anyone realizing it. They lasted only milliseconds, yet in that fraction of a second, they unleashed more energy than the sun produces in an entire day. There was no known astrophysical phenomenon that should produce such bursts, no easy way to explain why they would appear so suddenly, so intensely, only to fade back into nothingness. And for a time, they were believed to be like all the other strange signals before them. One-time events, cosmic hiccups lost to history. Until one of them came back. FRB 121102 changed everything. Discovered in 2012 and finally confirmed as repeating in 2015, it refused to behave like a transient signal. Most cosmic radio bursts flare once and are never seen again, but this one returned. Again and again, sometimes weeks apart, sometimes months, sometimes in rapid succession as though something, or someone, was sending them deliberately. It was found to be coming from a dwarf galaxy over 3 billion light-years away, a place so distant that whatever had created it had done so when life on Earth was still microscopic, when intelligence was a future so distant that it may as well have been another universe entirely. And yet, the bursts continued, hundreds of times, proving that FRBs were not just one-time cosmic accidents, but something stranger, something more persistent. The theories came swiftly. Some believed they were the signature of magnetars, highly magnetized neutron stars capable of emitting extreme energy under the right conditions. Others suggested they could be the product of black holes or some other unknown astrophysical process we have yet to understand. But then there were those who wondered if something else was at play. Because a signal that repeats, a signal that does not conform to the chaotic randomness of the universe, starts to look less like a natural event and more like something constructed. And if nature had not built it, then what? Or who had? Perhaps they are beacons, lighthouses of the cosmos signaling across unimaginable distances, pulses of energy sent not by accident, but with purpose. Or perhaps they are something more mundane, something that, like the wow, signaled before them, will eventually be explained away with new discoveries and better instruments. But until then, they remain one of the great mysteries of the modern era, a reminder that even in the depths of space, something is sending out a message, intended or not. And if we keep listening, if we refuse to turn away from the unknown, perhaps one day we will finally understand what, or who, is calling out from the other side of the void. And so, even as radio telescopes continued their patient search, listening for voices in the dark, another kind of mystery emerged. Not in the whispers of distant stars, but in the silent, high-energy echoes of the cosmos itself. Beyond the soft glow of starlight, beyond the faint hum of radio waves, there exists a realm of radiation so intense, so powerful, that it can only be glimpsed through the eyes of X-ray telescopes. And in that hidden spectrum, deep within the Perseus cluster, astronomers found something that should not be there. The Perseus cluster, a massive congregation of galaxies over 240 million light-years away, is one of the most energetic and turbulent regions of space ever observed. It is a place where galaxies are locked in an ancient gravitational waltz, where superheated gas drifts between them at millions of degrees, glowing in X-rays as it is shaped by the relentless pull of gravity. It is in this chaos that something unexpected was discovered. A strange, unidentified X-ray emission, a spectral fingerprint that matched nothing known to physics. Ordinary X-ray emissions have an explanation. They come from black holes, neutron stars, or the scorching plasma that fills the gaps between galaxies, all of which can be traced back to the familiar forces of nature. But this signal was different. It did not match the signature of any known element, nor did it align with the emissions expected from the immense black hole at the center of Perseus. It was a faint, elusive anomaly, sitting at an energy level where nothing should be producing X-rays. And so, the question arose. If it was not coming from anything we understood, then what could it be? The answer, some believe, lies in one of the most elusive mysteries in all of physics: dark matter. An invisible substance that outweighs everything we can see, yet has never been directly observed. Dark matter is thought to make up the vast majority of the universe's mass. It does not emit light, it does not interact with ordinary matter in any way we can detect, but its gravity shapes galaxies, bends the paths of stars, and holds together the grand architecture of the cosmos. And if the signal from the Perseus cluster is what some suspect, it may be the first direct evidence that dark matter is not entirely silent. That under the right conditions, it may reveal itself in the form of exotic X-ray emissions. One particular candidate for this mystery is the sterile neutrino, a hypothetical particle that, if real, could decay over vast cosmic timescales, releasing faint X-rays as it vanishes. If the Perseus cluster's strange signal is indeed the echo of dark matter particles disintegrating, then it would mean that for the first time in human history, we are not just feeling the gravitational tug of the invisible universe. We are finally seeing its light. But as always, there is doubt. Some argue that the signal is nothing more than an instrumental artifact, a trick of the data, or an ordinary astrophysical process yet to be understood. Others suggest that even if dark matter is involved, it may not be the explanation we are looking for. The signal has since been detected in other galaxy clusters, adding to the intrigue, but never quite solidifying into proof. And so, much like the radio signals that tease us with the possibility of intelligence beyond Earth, this X-ray mystery stands at the edge of certainty. An unanswered question, lingering in the void, daring us to uncover the truth. And so, we look deeper. Because the universe is not merely what we see. It is what we do not see, what we suspect but cannot yet prove. And if dark matter is whispering to us through the Perseus cluster, then the greatest discovery in physics may not be found in a laboratory, but in the silent echoes of galaxies that have been hiding the answer all along. And so, as astronomers strain their eyes toward the distant reaches of the cosmos, hoping to glimpse the invisible forces that shape the universe, another mystery stirred much closer to home. Deep within the heart of our own galaxy, where the night is never truly dark, where the gravitational presence of a supermassive black hole bends the fabric of space itself. It was here, near the Milky Way's core, that something began to speak in radio waves. Something unlike anything we had ever heard before. This signal did not hum with the steady precision of a pulsar, nor did it roar with the chaotic fury of a black hole consuming matter. Instead, it pulsed unpredictably, vanishing for weeks or even months at a time, only to return without warning, as if it existed in a realm between presence and absence, between certainty and the unknown. At first, it was mistaken for a typical transient signal, a brief flare from some forgotten star. But the more scientists observed it, the stranger it became. Unlike known pulsars, whose precise rhythms are governed by the relentless spin of neutron stars, this signal did not keep time. It flickered into existence in a way that defied classification, as if its very nature was not bound by the same rules that govern ordinary celestial bodies. The theories came swiftly, each one more intriguing than the last. Perhaps it was a new type of neutron star, one that had fallen into a state of decay unlike any we had seen before, flickering in its final moments before slipping into darkness. Perhaps it was a white dwarf, an ancient stellar remnant whose magnetic field had become twisted and unstable, producing radio bursts that refused to follow conventional patterns. Or perhaps, just perhaps, it was something entirely new, a class of object that had been hiding in plain sight all along, waiting for our technology to become sensitive enough to detect its presence. The best theories suggest that it may belong to a family of objects known as magnetars, highly magnetized neutron stars capable of releasing sudden bursts of energy as their intense fields shift and crack. But even that explanation does not fully account for its strange behavior. It does not shine in X-rays as magnetars do, nor does it fit neatly into the categories we have spent decades refining. And so, like the WOW signal before it, like the unexplained X-ray whisper of the Perseus cluster, this anomaly lingers at the edges of our understanding, a reminder that for all we know about the universe, there is still so much that evades us. It is these kinds of mysteries that push us forward. Every time we think we have mapped the cosmos, that we have assigned a name and a function to every strange light in the sky, something like this emerges. A ghostly transmission from the galactic abyss, pulsing on a schedule that we cannot yet comprehend. Perhaps, in time, we will find its origin. Perhaps it will become another solved equation, another entry in the ever-growing book of astrophysical phenomena. Or perhaps it will remain, as so many things in the universe do, a riddle without an answer, a signal lost in the noise of creation, waiting for us to finally understand what it has been trying to say. And so, as we drift from the distant realms of the cosmos, from the swirling formations of galaxies and the abyssal mysteries they hold, our attention is drawn closer to a world both familiar and alien, a world wrapped in golden clouds and secrets. Venus, Earth's twisted twin, its surface a vision of apocalyptic ruin, where the air crushes like the depths of an ocean trench, and the rain, if it falls, comes down in droplets of pure acid. A planet long considered inhospitable to life, its infernal landscape the very antithesis of anything we might recognize as a cradle for existence. And yet, in 2020, a signal emerged, a whisper in the winds of its atmosphere, a chemical fingerprint that had no business being there, phosphine. A molecule that, on Earth, is woven into the fabric of biology, produced by microbial life in oxygen-starved environments, bubbling up from the decay of organic matter, an invisible breath of unseen things. It was found in the clouds of Venus, high above the lethal wasteland below, where the conditions, though still harsh, are milder than the nightmarish inferno beneath. The discovery sent a ripple through the scientific community, a tremor of both excitement and caution. Could this be a sign, however faint, of life hidden in the thick, yellow haze? A strange, alien ecosystem clinging to existence in the floating twilight of Venus skies? The idea was intoxicating, unsettling, almost too poetic to be real. A planet once thought to be Earth's sister, now possibly holding life in the most unexpected of places. But science does not bow to poetry alone. The skeptics rose, their arguments like stones thrown into the pond of speculation, questioning whether this detection was truly what it seemed. Instruments can deceive, signals can be misread, and phosphine, though tied to life on Earth, can also be forged in the heart of chemical reactions indifferent to biology. Could the planet's volcanic activity be crafting this molecule in ways we do not yet understand? Could some exotic process, one unique to Venus and its brutal chemistry, be toying with our expectations? The debate raged on, studies revisiting the data, scrutinizing the very fabric of the detection, questioning whether the signal was even real or merely a trick of observation. Telescopes turned their gaze back toward Venus, measurements were taken, theories proposed and dismantled. Some believed the phosphine was there, but in lesser quantities than first reported. Others suggested the readings were flawed, an illusion born from the complexity of spectral analysis. And yet, despite all the caution, all the skepticism, the question lingers unresolved. If the phosphine is real, and if it is not born from mere chemistry, then what is left? An answer both thrilling and terrifying. Something, somewhere, in that alien sky, might be alive. But if such life exists, it is unlike anything we have ever known. It would be a life form adapted to an environment where sulfuric acid forms the very essence of rain, where water is a rarity and survival a balancing act against forces that would destroy an earthly organism in an instant. It would be a life born not from comfort, but from endurance, from the strange alchemy of survival in a place where survival should not be possible. Perhaps it is microscopic, drifting within the thick Venusian clouds, existing in a way that defies our definitions, rewriting what we thought we understood about habitability. Perhaps it is something even stranger, something we have yet to even imagine. The mystery remains, and so does Venus, turning beneath its eternal clouds, a world that has watched the Earth for eons, its secrets locked away beneath an atmosphere that veils more than just its surface. If life is there, it will not reveal itself easily. The universe does not surrender its mysteries without a fight. But the search continues, the questions echoing into the void, because to look for life beyond Earth is not just a scientific pursuit. It is a whisper of something deeper, something that has stirred within us since the moment we first gazed at the sky and wondered, in the quiet spaces of our minds, if we were truly alone. The search for life beyond Earth is a pursuit of whispers in the dark, of faint signals and strange anomalies, of things that should not be yet persist in defying our understanding. Venus and its phosphine mystery raised the possibility that life could hide in the thick, acidic clouds of a world we long considered barren, but there are other places, far more distant, far more enigmatic, where something unusual lingers in the starlight itself. Tabby Star is one such place. It sits over 1,000 light years away, an unremarkable point in the sky to the naked eye, yet through the lens of scientific curiosity, it becomes something far more intriguing. Its light does not behave as it should. Most stars flicker and dim in predictable rhythms, their changes dictated by known forces. Orbiting planets, shifting dust clouds, the natural pulsing of stellar evolution. But Tabby Star is different. Its light fades in erratic, chaotic patterns, sometimes dropping by a fraction of a percent, sometimes plunging by as much as 20%, only to return to normal as if nothing had happened. No known planet, no ordinary cosmic debris, no simple explanation fits. And so, speculation took flight, reaching into the realm of the extraordinary. What if this was not a natural phenomenon? What if we were witnessing something constructed, something artificial, something vast? A structure of unimaginable scale, built to harness the energy of an entire star. A Dyson sphere. It is the kind of idea that stirs something primal, something beyond logic, because it speaks to the notion that we might not be the first, that somewhere, out there, another civilization has done what we can only dream of. But science is a cautious thing. Theories were tested, alternative explanations pursued. Could it be an enormous swarm of comets blocking the light in unpredictable waves? Could it be vast clouds of dust, lingering between us and the star, shifting in patterns we do not yet fully grasp? The evidence remains inconclusive, the mystery unsolved, and the possibility, however remote, still lingers in the depths of space. And then there is KOI 817c, another enigma in the endless sky. It, too, dances in the light of its star in ways that should not be. An exoplanet candidate, a world in a system unlike our own, its presence is marked by variations in brightness that do not conform to simple orbits, do not fit neatly into the rules we expect. Could it be a world with an atmosphere so thick and turbulent that it distorts the light in ways we have never seen? Could it be a planet locked in some gravitational struggle with unseen forces, its passage through the cosmos altered by the pull of hidden companions? Or could it be something else, something crafted, something that was not placed there by nature alone? The question of extraterrestrial engineering is one that lingers at the edges of scientific inquiry, always present yet never confirmed. We search for the unexplainable, hoping that one day we will find something that does not fit into the patterns of the universe as we understand them. And perhaps one day, we will look at a distant star and know, with certainty, that we are seeing the handiwork of another intelligence, one that has left its mark upon the cosmos in a way that cannot be mistaken. Until then, the light of Tabby's star will continue to flicker, the mystery of KI 817c will remain unsolved, and we will keep watching, keep searching, because somewhere, in the vastness of space, an answer awaits. The search for the unknown is not always about looking outward into the abyss of deep space. Sometimes, the mysteries lie closer, within the familiar glow of our own solar system, hidden in plain sight yet defying explanation all the same. The distant flickering of Tabby's star and the strange rhythms of Ki 817c raised questions about the nature of celestial structures. Whether they are born of nature's chaotic hand or something more deliberate, more constructed. But there is another anomaly, one that does not whisper in dimming starlight or distant orbits, but instead stares back at us from within the golden hues of Saturn itself. A storm, vast and violent, yet impossibly precise, an unbroken shape carved into the planet's clouds for reasons we still do not fully understand. At Saturn's North Pole, an immense hexagon has lingered for decades, turning with the planet, unmoved by the chaos of its surroundings. A storm over 20,000 miles across, its edges sharp, its structure unwavering, as if nature had abandoned its tendency for randomness and chosen, instead, the clean geometry of an architect's hand. It is not the kind of thing one expects to see in the swirling, ever-changing dance of a gas giant's atmosphere. Storms should twist and spiral, fold into themselves, dissolve and reform in a pattern of endless flux. And yet, here is a hexagon. 6 equal sides, holding their shape as if guided by something unseen. The first time we saw it up close, it was through the lens of Voyager, drifting past Saturn in the 1980s, capturing images that raised more questions than answers. And when Cassini arrived decades later, expecting to find change, it instead revealed something even stranger. The hexagon was still there, still perfect, still maintaining a form that should have long since unraveled. The simplest explanation, or at least the one that makes the fewest assumptions, is that it is the result of standing atmospheric waves. Currents locked in a feedback loop of motion, pushing against each other in a way that stabilizes the pattern. Laboratory experiments with rotating fluids have shown that such shapes can form under the right conditions, though none on a scale as vast as what we see on Saturn. But even as scientists piece together the physics that might sustain this hexagonal storm, the fact remains that no other planet we know of, in our solar system or beyond, exhibits anything like it. And so, the inevitable question arises. Could something unnatural be maintaining it? Could it be an artifact, a structure hidden within the clouds, manipulating the winds into a shape that should not exist? The idea is tempting because we are drawn to patterns, to order where there should be none. It is the same reason we search for meaning in the flickering of distant stars, why we wonder if strange dimming is the work of colossal megastructures rather than mere dust and gravity. It is the same impulse that makes us ask, when faced with something we cannot immediately explain, whether it was shaped by intention rather than chance. But whether artificial or natural, the hexagon remains a reminder that the universe is not finished surprising us. It spins at Saturn's pole, as it has for years, as it will for years to come, a silent enigma carved into the atmosphere of a distant world. If there is an answer, it is locked within the clouds, waiting for the next traveler, the next machine, the next eye to gaze upon it and wonder. And wonder we will. The universe has always been a stage for the strange, a canvas of phenomena that defy easy explanation. From the unearthly geometry of Saturn's hexagonal storm to the erratic dimming of distant stars, we have learned that the cosmos does not always conform to what we expect. But mysteries are not confined to the vastness of space. Some linger much closer, in the quiet, shadowed places of our own world, waiting in the corners of the sky where logic and folklore meet. In a remote valley in Norway, beneath the cold stretch of northern heavens, there are lights that move in ways no one can quite understand. Glowing orbs that appear without warning, hovering, darting, fading into nothingness, only to return again, indifferent to those who watch. For decades, the Hessdalen lights have played their silent game, drifting through the valley with an eerie consistency that has left both scientists and locals grasping for answers. Unlike fleeting UFO reports that rely on the hazy recollections of startled witnesses, these lights are real, persistent, recorded and studied, yet still wrapped in uncertainty. They come in different forms: bright white, deep red, electric blue. Sometimes small, sometimes stretching to the size of a car, moving too fast for aircraft, too erratically for satellites, too controlled for random flashes of lightning. They hover for minutes, dance along the ridges of hills, then vanish without a trace. And they always return, as if Hessdalen itself is their chosen stage. Scientists have come, drawn by the sheer undeniability of the phenomenon. Observatories have been set up, cameras left running through the long nights, hoping to catch a glimpse of the unknown in action. Some theories suggest the lights are born from natural processes, the result of rare interactions between minerals in the ground and the charged particles of the atmosphere. A kind of slow-motion lightning, emerging from the valley's unique geology, charged by underground currents or atmospheric plasma, forming luminous spheres that drift like ghostly embers. Others have pointed to ionized dust, strange weather patterns, even unknown forms of ball lightning, trying to explain how Hessdalen can glow without a clear source. And yet, no explanation fully fits. The lights do not behave as simple plasma should. They do not flicker and fade in a way that aligns with the mechanics of electrical discharge. Some have been seen accelerating in ways that defy conventional aerodynamics, shooting off at speeds no known natural process should produce. Instruments fail to pin them down. Readings fluctuate without clear reason, and the deeper the investigations go, the more the mystery deepens. There are those who whisper of something artificial, of technology beyond what we know, hidden in the sky above the valley. The idea of something watching, something testing, something using Hessdalen as a point of contact. The thought is unsettling, yet impossible to dismiss entirely. The valley remains silent and patient, the lights still coming as they always have. Some nights they appear, some nights they do not, indifferent to our attempts to unravel their origin. Perhaps one day the answer will come, and it will be simple, obvious in hindsight, a quirk of nature that we failed to see. Or perhaps, long after we are gone, the lights will continue to dance over Hessdalen, a riddle never meant to be solved, a quiet reminder that not all things in this world, or beyond, are so easily explained. Some mysteries linger in place, waiting for us to stumble upon them, like the Hessdalen lights, flickering in the cold silence of a Norwegian valley, or Saturn's hexagonal storm, turning ceaselessly in the gas giant's eternal winds. But others do not stay still. They pass through, slipping between the cracks of our awareness, here and gone before we can grasp them. Fleeting visitors from the void, carrying secrets we may never fully understand. For most of human history, we believed the solar system was an island unto itself, its asteroids and comets bound by the sun's gravity, looping endlessly in predictable orbits. But then came something that did not belong. A sliver of motion against the backdrop of stars, moving too fast to be captured, slipping through like a message written in the language of celestial mechanics. We named it Oumuamua, Scout in Hawaiian, as if even in its name we acknowledged the strangeness of its arrival. Unlike any asteroid or comet we had ever seen, it tumbled through space not in the chaotic spin of a broken rock, but in a steady, deliberate roll. Its shape was bizarre, elongated, more like a shard or a sliver than the rounded or jagged profiles of ordinary space debris. It had no tail, no visible outgassing, yet it accelerated as it left our solar system, as if something unseen had given it a push. The possibilities unfolded before us like a puzzle with missing pieces. Could it be a fragment from a shattered world, ejected from some distant star system, wandering the emptiness for eons before finally crossing our path? Or was it something else? Something crafted, something sent, something watching? The idea of an interstellar probe, a vessel from another intelligence, was impossible to ignore. Oumuamua did not behave like a normal rock. Its motion defied expectations, its silence almost too perfect. There were theories. Perhaps it was a fragment of nitrogen ice, reflecting light in deceptive ways, or a strange, pancake-thin shard pushed by sunlight itself. But the truth remains elusive, locked in the void, because Oumuamua never stayed long enough for answers. It was already moving away when we found it, fading into the distance, lost beyond the reach of our telescopes. Then, as if the universe did not want to leave us with only a single visitor, another came. 2 Borisov. But Borisov was different. More familiar, more like the comets we knew, trailing gas and dust as it passed. An interstellar traveler, yes, but one that seemed more ordinary, more natural. And yet, its presence confirmed something extraordinary. Our solar system is not isolated. Things drift in from the depths of space, passing through like whispers from distant places, carrying with them the stories of worlds we will never see. Perhaps Oumuamua was nothing more than a peculiar shard of rock, shaped by forces we do not yet fully understand. Perhaps it was the relic of a shattered planet, lost in the chaos of interstellar space. Or perhaps, just perhaps, it was something else. A probe sent long ago, its purpose unknowable, its journey dictated by the silence between the stars. Whatever it was, it is gone now, beyond our reach, leaving behind only questions. And so we watch, waiting for the next visitor, the next anomaly, the next whisper from the void, wondering what message, if any, they carry. The universe has a way of teasing us, offering glimpses of something extraordinary, only to pull it away before we can be sure of what we saw. Oumuamua came and went before we could truly understand it, an interstellar visitor slipping back into the dark, leaving only speculation in its wake. But sometimes, the mysteries do not come in the form of silent travelers. Sometimes, they arrive as a sound. A whisper in the static, a flicker of data on a screen, a pattern where there should be only noise. For those who search for life beyond Earth, the dream is always the same, a signal, unmistakable in its structure, coming from the depths of space, proof that we are not alone. And for a brief moment, 2 signals, BLC-1 and the Green Bank signal, seemed as if they might be just that. BLC-1, a narrowband transmission detected in 2020 by the Breakthrough Listen project, came from the direction of Proxima Centauri, the closest star to our own. It was steady, unmodulated, with no clear earthly source, and for a time, it defied explanation. There were no known satellites in its path, no simple interference that could account for its presence. It was the kind of thing SETI researchers dream of, something that did not immediately vanish under scrutiny. And yet, when deeper analysis was done, the truth was more frustrating than wondrous. The signal, though intriguing, bore all the hallmarks of human-made interference, a radio artifact bleeding through from our own technology, hiding within the cosmic static. It was not the voice of an intelligence beyond our world. It was an echo of ourselves. The Green Bank signal, detected years earlier, had followed a similar trajectory. A burst of radio waves, seemingly artificial, briefly igniting excitement before the inevitable unraveling began. This one, too, was not what it first appeared to be. Another false positive, another reminder of how difficult the search for extraterrestrial intelligence truly is. The universe is loud with radio chatter, but most of it comes from us. Our satellites, our devices, the endless hum of our own civilization spilling into the sky. The deeper we listen, the more we find signals that seem promising at first, only to collapse under scrutiny, dissolving into the mundane. False positives are common in SETI research, not because scientists are careless, but because the line between the natural, the artificial, and the extraordinary is thinner than we would like to believe. A signal from an alien world would not arrive with a clear label announcing its presence. It would be buried in noise, indistinguishable at first from the countless other transmissions that fill the cosmos. And so, each new discovery must be met with caution, tested and tested again, because the universe does not give up its secrets easily. But the search does not stop, because one day, among the countless signals mistaken for something more, there may come one that does not fade under analysis, one that does not dissolve into interference or human error, one that lingers, undeniable in its origin. And if that day comes, we will be listening. The search for answers is never easy, and perhaps it was never meant to be. We listen for whispers in the cosmic static, track fleeting visitors from the depths of space, and watch as strange lights dance in the night, always reaching, always wondering. Each discovery brings us closer to understanding, yet with every step forward, the unknown stretches even farther, revealing more questions than we ever imagined. The Hessdalen lights remain, flickering without explanation. Saturn's hexagonal storm continues its endless rotation, locked in a pattern that defies expectation. Oumuamua has vanished into the dark, carrying its secrets with it, while radio signals, promising at first, dissolve into the ordinary, leaving us to wonder if the real message is still out there, waiting. Theories abound, some grounded in physics we have yet to grasp, others reaching toward the extraordinary. The fabric of the universe itself may hold secrets we barely comprehend, hidden in the mathematics of reality, in the unseen forces that shape the cosmos. Or perhaps the answer lies elsewhere, in minds not our own, in civilizations that drift among the stars, watching, waiting, leaving behind traces too subtle for us to recognize. But for all our searching, for all our listening, the universe does not yet reveal its hand. It holds its mysteries close, allowing only glimpses, like shadows cast against a wall, always out of reach. Maybe one day, the puzzle will come together, and we will see the full picture, understanding at last the strange forces that shape the cosmos, the hidden currents that guide interstellar visitors, the meaning behind signals lost in the void. Or maybe, the deeper we look, the more complex the mystery will become, drawing us ever further into the unknown, reminding us that some questions are not meant to be answered, only pondered, only pursued, always just beyond the horizon. And so we wonder, of all the mysteries that linger, which one holds the key to something truly groundbreaking? Which one, if solved, would change everything? Perhaps the answer is waiting, just beyond the reach of our understanding, daring us to keep looking, to keep asking, to never stop searching.